we're going to learn about image formation in a convex mirror. You know, convex mirror is one where the bulging out surface is reflecting, right? As you all know, the back side of a spoon acts as a convex mirror. Now, if you take a spoon and look into the back side of the spoon, you will see if you move the spoon to and fro towards yourself, away from yourself, the image that you see in the spoon is always erect and diminished, right? That means in a convex mirror, the image formed always is virtual, erect and diminished, whatever the position of the object may be, right? As in case of plane mirror, it is always virtual, erect and same size, and a convex mirror, it is always virtual, erect and diminished. So we are going to learn the image formation in convex mirror through ray diagrams. Now for drawing the ray diagrams, as you already know, in the last class we learned that we need to choose two incident rays for drawing the ray diagram, and we can choose any two rays of the following four rays that I am just drawing in front of you. The first ray that we can choose for drawing a ray diagram is, we know now whenever you draw a convex mirror, you always use a compass. C is behind the mirror, as you know. This is your pole, and F is just midway between P and C. This you all know, this you always have to follow, right? Now, if the incident ray is parallel to the principal axis, reflected ray appears to pass through focus. This is one of the rays that we can choose for drawing our ray diagram, fine? If the incident ray is parallel to the principal axis, reflected ray appears to pass through focus, okay? Second ray that we can choose for drawing a diagram is, now, we know that the reverse should also be true. So, in the second diagram, we say if the incident ray is in the direction of the focus, that means if this is your incident ray falling in the direction of focus, the reflected ray will be parallel to the principal axis. Okay. So, out of these two rays, we can choose any one for drawing a ray diagram. There are two more rays that we can choose. Let's do that. The third ray that we can choose is, now, the third ray is, if the incident ray is in the direction of C, is towards center of curvature, that is your incident ray falling on the mirror in the direction of center of curvature. Where will the reflected ray be now? Now, the reflected ray will be back along the same path, and we all know why, because any line joining the mirror to the center of curvature is the normal to the mirror. So, if the incident ray is along the normal to the mirror, the reflected ray will be back along the same path along the normal. Angle I as well as angle R for this ray will be 0. The fourth ray that can be chosen for drawing the ray diagrams is if the incident ray is now falling at the point P. Fine. Please remember always whenever you draw a diagram, use a compass, mark C, P and F should be exactly midway between P and C. This is always to be followed, that's why I keep repeating this. Now the fourth ray that can be chosen is if the incident ray falls onto the pole, the reflected ray will be also reflected in such a way that it makes the same angle with the principal axis, because you know principal axis is the normal to the mirror, fine? So if the ray is falling at point P, the reflected ray should be made in such a way that angle I and angle R are equal. The angle that the incident ray makes with the principal axis should be equal to the angle that the reflected ray makes with the principal axis. So out of these four rays that we've just drawn, we can choose any two for drawing our ray diagrams. Okay. As we know, in a convex mirror, the nature of image is always virtual, erect and diminished. So we don't have so many ray diagrams. We only draw two ray diagrams. One for the object at infinity and the other for the object anywhere between infinity and the pole. Fine. So now case 1 therefore is object at infinity. So case 1 that we choose is object at infinity. Fine. So what we are doing is we have to take object at infinity. That means we don't have to show the object in the diagram. We mark C, use a compass. You can take distance between P and C as 6 cm. Mark F midway in between, and for the case 1 object at infinity, we will not show any object, and we know because the object is at infinity, rays are parallel, coming from the object parallel to each other. So these are the incident rays falling from the object onto the mirror. Reflected rays will be in such a way that they appear to pass through focus. Obviously, the reflected rays will be like this. The reflected rays, the two reflected rays you can see are diverging in such a way that they both appear to pass through focus. Fine. So that means the image, the rays appear to meet at focus. The rays are not actually meeting, they appear to meet at focus. So where is the image formed? Image therefore is formed, we say is formed at F. What is the nature of image? And rays are not actually meeting, intersecting. So the image is virtual, erect. And what is the size of the image? Point sized or highly diminished. So this is case 1 for convex mirror. When the object it has infinity, image is at focus, virtual, erect and highly diminished image is formed. As you can all see, the rays which I have drawn behind the mirror, the extended rays that I have drawn I've drawn them in the dotted form. Please do follow this. Draw the extended rays always in the dotted form. Okay. So this is case 1. Now case 2 is object between P and infinity. Object we can choose anywhere between pole and infinity. So we have to choose object anywhere between P and infinity. So we draw FC and I am drawing an arrow here in front of the mirror which is representing our object. It can be drawn anywhere in front of the mirror. So now from the tip of the arrow, we draw two incident rays. One ray, let me draw it parallel to the principal axis, and you know where the reflected ray will be. It will be passing through focus. It appears to pass through focus. It's actually passing through focus. It appears to pass through focus. It is in the direction of focus. So rays like this. This is the reflected ray. Now second incident ray. Now second incident ray, we can make it passing through the ray which appears to pass through C, in the direction of C. So that second incident ray can be drawn like this. As you can see. So this is the incident ray. Reflected ray will obviously be back in the same direction. This is the reflected ray. So this is one reflected ray. This is second reflected ray. And the rays, if we extend them at the back of the mirror, they appear to meet at a point here. So for point A, let me see, this is A, this is B. For point A, this is the image. So this arrow, A dash, B dash, is representing the image. So object is between P and infinity. Image is always formed behind the mirror. It is behind the mirror, as you can see. And as you can see, it is always formed between P and F. The image is always formed between pole and focus. Fine. The nature of the image is virtual erect. You know why? Because the rays are not actually meeting. They just appear to meet. So image is virtual. Erect, we can see the image is above the principal axis. So the image is erect. And size, as can be seen from the diagram, is diminished. So the image formed in a convex mirror is always virtual, erect and diminished. Whenever you're drawing a ray diagram, please ensure that you're marking the arrows properly. You're drawing the extended rays with a dotted line, and you're writing this information: position of object, position of image, nature of image, and the size of the image. This is must whenever you're drawing a ray diagram. For convex mirror, there are only two ray diagrams. Both the ray diagrams show us that the image formed in a convex mirror is always virtual, erect, and diminished. And that's all for the day. In the next class, we're going to talk about the uses of the mirrors, of all the three types of mirrors. We know plane mirror, concave mirror, and convex mirror. So that's it.